way for a person to be able to look at a set of values and determine something about the shape of the distribution and position of certain things in the distribution. There's two types of analysis that we can do. The 5-number summary is a simplistic way to be able to look at a distribution of values. The more complicated way is a normal distribution approach, but that requires and shows you how you use both the mean and the standard deviation, which we'll be getting into today, how you use those together. Okay, so in this particular problem, if we're going to move to its graph in the box plot, then there are certain things that we expect to be present in a box plot. A box plot is expected to contain information about the 5-number summary, which we have up here at the top, and the outliers. It provides a visual, let's pulling that right. It provides a visual, or a graphic, if you will, to make decisions on the shape of the distribution. Okay, so if you were going to, by the way, outliers is a good word, and I'm going to add it to the dictionary, okay? If you were going to create a box plot of this particular data, you would have started by needing some kind of a line, some kind of an axis scale. Now, graph paper is excellent for box plots. The problem with graph paper is you've got fixed widths and you have to kind of jury-rig the scale to be able to make sure you see everything in the problem. So to make this easier, what I would suggest is when you have to do a box plot, what you would want to do, if it is possible, is to use a straight edge that's got a ruler marking on it so that you have nice intervals that are already laid out. What you assign the width of those intervals to be depends upon what scale values you need to see in the problem. So since the 5-number summary has to contain, since the box plot contains all the information about the 5-number summary, and it also contains the outliers, then I need to be able to see as far back as a -5, and I might want a little bit of elbow room on the outside, and I need to be able to see out at least to 88 because it's outside the fence. It's farther out than the fence in the problem. Sometimes your fences are your largest and smallest values in the distribution. Sometimes you've got an outlier, so you have to look at all 7 of the values and figure out how much space. Now, going from -5 to a positive 88 is kind of an awkward scale. So usually what we try to do is to get some nicer numbers to round those values off. So I would say that I need to see enough space that runs from a -10 all the way out to maybe a positive 90. I could go to 100 if I wanted to. But if I go to 90, that's enough space to be able to capture everything and have enough room for a little border to be able to put it in a picture to put on the refrigerator so your parents are proud of you. Okay? That's what happened in 3rd grade, right? Doesn't happen here. Although some of your parents may still give you perks like that. Now, that's not going to be an easy thing to do if you try to guess at the distances. So it's better with that ruler down there so that you can say, this is what I'm going to let each one of the units represent. Now on a ruler, you've got 12 nice little subdivisions in there because you've got your 0 inch, your 1 inch, your 2 inch, your 3 inch, and so on down the line. If you need more than 12 spaces, turn the rule over and use a centimeter scale, or use the 1/2 inch markings in there. But you want to be sure that you don't get too small of a graph because it's going to be difficult to read and to label, and you don't want a bigger graph that fits on a piece of paper. So we don't get extra points for poster board, okay? So that doesn't do us any good. So just right is better than too small or too large. So I'm doing something that you would never do if you were doing this, and I'm going to be guessing at what my distances are going to be. This is where my -10 marking is going to be. That's going to be 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. Now that I know where 90 is, then there's nothing wrong with leaving more line than you need, but I'm going to shrink it back. Now the danger of me just randomly making marks is that I don't necessarily get the same distance between each one. And that means you have a potential visual distortion to your graph or an optical illusion that my father used to refer to as optical conclusions, because if you distort the graph, people draw conclusions off of your graph, and if your graph's faulty, then it's not really very good. So, finish labeling it out. I would not have to label every value that sits on here, but I need to label enough that someone else could be able to follow it down my line. One of the problems with box plots is you have numbers that might not necessarily be on the scale like you have to have it. So you very seldom see a box plot that tick marks everything between each of the individual values, because I'm not wasting my time putting 10 values between -10 and 0, and between 0 and 10 and so on down the line like that. So your graphs might be a little bit rough if you did them by hand, but they should not be so distorted that they lead a person to believe something that's not actually true. So what do we put on the graph first? You can really put anything you want on the graph first, but I'm in a habit of putting in the fences to begin with, because most of the time, those are the largest and smallest values that we would see in the distribution. So I have a fence that goes at -5, and the fences are put in using brackets. And you have to kind of guess where -5 is, but so that your reader doesn't get confused and not know what it actually represents in case they lost the list of data, it's not a bad idea for you to label each of the values that you put on the graph as well. You'll have to do a box plot on at least one exercise out of the workbook, and that's the only time you'll ever have to do a box plot, but I would like that box plot not to be something that looks like a third grader did it. So put a little bit of thought into it, okay? And my upper fence is at 75. So those two boxes, or those two brackets, are about the same size, and we already see a small issue that we're going to have to deal with, in that one of our values that has to appear on the graph is outside of the fence. Okay, well, we'll get to that when we get to it. Now I go back to the 5-number summary. My minimum value is 10. You can do one of two things. You can either put a small hash mark there, or you can put a dot. Question?
You're in the wrong spot. You're on like 85.
Oh, okay, thank you. So 75 should be over here, huh? If you're not careful and can't read, like me, then you do simple mistakes. So 10, either you're going to put a single dot there, because it's a point, or you put a little hash mark, because it's easier to see, or you just don't put anything there, which is a bad thing to do, okay? Quartile number 1 is at 25, and 25 is approximately halfway between the 20 and the 30, not approximately, it should be halfway in between, and that's going to be a little bit larger bar, maybe the same height as your fences, maybe not, but you don't want all the bars to be the same, because you're going to get a box in here and you want to be able to see the box, so you want to have kind of a good distance in there. So this value now is where 25 is. Median value is at 31, and this is where you start getting problems. That 30 is not exactly what you need, and it's one of the good reasons why you put a value up above there, so that the person looks at that, and if they don't have the data, they know what it represents. Then our third quartile is at 45, so we've got a nice little boundary line that sits in there. And the distance that goes between quartile number 1 and the quartile number 3 is where we get the box part of our box plot. So those are connected off, so you have a nice box, which gives you an idea about why you want to have a box that's, at least those bars should be big enough that you can see the box and not have it be a real skinny little box. You like to have some bulk to it, some substance to it. And the maximum value now is 88. But 88 is outside of the fences, therefore it is an outlier. Any value which lies outside the fences is identified with an asterisk. Box plots used to be called box and whisker diagrams until it got insulting to statisticians, and they changed the names to box plots. And you have a couple of extensions that come off now. There's an extension that runs off of Q1 back as far as it needs to go to hit the minimum value or the fence. You never extend from quartile 1 or quartile 3 outside of the fences. Some things may be outside the fences, but that means here when I go from quartile number 3 out, I am obligated to stop at the fence. And if you think of fences in a broader sense, people put fences around their property because they don't want people to come in, or sometimes they don't want their things to get out. People put a fence around their backyard because they want to keep their dog inside the backyard. Some people put 8-foot fences with barbed wire at the top of them because they don't want people to get out.